Okay, today we're going to look at a new topic called absolute value, and we're going to look at solving some absolute value equations. In some of the literature, you might also find that this is listed under the topic of modulus, of finding a modulus of a number or so. All right, what exactly am I talking about? So let's start out. What is an absolute value? So an absolute value of a real number, let's just call it x, our favorite letter, will symbolically be written as an x with two parallel or between two parallel lines. And the formal definition is x is equal to itself if x is non-negative, and negative x if x is negative or less than 0. Yes, all right. Yes, you did hear me correctly. I did say that this is non-negative, while this is negative. And there is a slight distinction between what we mean by a positive number versus a non-negative number. All right, so let me just do a bit of an aside first and talk about these things. All right, if we have, so let's look at some of the symbolism. Whoops, as I told you, spelling is not my strong suit. All right, so let's look at, let's say that x is some real number, and we can write the algebraic statement x is greater than 0, which you know. And what do I mean by that? So examples of x could have been, say, 0.2, 1, and so on, 1.7, 27, etc. All right, and here we say that these are just positive numbers. However, if I should look at the greater than or equal to sign, then again possible values of x are 0 or as I listed above, 0.2, 1, and whatever else you felt like. If we examine this, we have 0 and we have the positive numbers. So together, when I have a positive and 0 could be included, then we make reference to this and say that overall this is a non-negative number. Right? The same thing applies if we were doing or working with the less than 0 or less than or equal to symbol. All right? So oftentimes, if I wrote x is less than 0, you can hear me saying that this is just negative. But once I've included the 0, x is less than or equal to 0, then I will write this as non-positive because the 0 is included. All right, so it's a slight, it's a distinction between the two things. Symbolically, many of you already understood that the difference between, say, the strict inequality and the inequality that has an equal sign, right? So the difference between greater than and equal to was either the absence or presence of 0. But you probably weren't as familiar with the words. Okay. All right, so let's go back to what we were doing. All right, so we have this, we understand, or the symbolism that we have is an expression, in this case some number, which I'm calling x, is written between two parallel lines, and it has a definition, a two-line definition. And let's see exactly what I mean now. So let's look at some examples. If we asked you to find the absolute value of 2, well, what you would do is basically you would say to yourself, since 2 is greater than 0, we'll use the top line, and the top line gave us that we should just really write the expression, the number that was between the two parallel lines. The next one, if I ask what is the absolute value of 0, in the same way, we can say since 0 equals 0, or if I want, I can even say 0 is greater than 0. Both of these statements are true. So again, I will use the top line, and I will tell you that the result, the absolute value of 0 is 0. All right. Let's let's do something. Let's do another one. Right. So these are kind of trivial examples, and let's look at absolute value of -3. Based on what I have here, I would again go back and sort of ask the same question. What can I say about -3? Since -3 is less than 0, this time I'll use the bottom expression, right? And hence, I will say I want the negative of -3, the negative of the expression. So this is my x. Here's my x. I'm taking the negative of it, which when we work out is really just +3. All right. Now, just based on these three simple examples, we should see something. If all of these we have an input, input can be positive or negative. But when we look at the output, the answer, output is always, or the result is always positive coming out from this. All right, so shorthand would be a plus, and I'll just put a plus sign. Will always be positive. Okay. All right, so the coming out of this absolute value, we always end up with a positive number. We can ask, well, what good is this? What's the meaning? Well, let's look on a number line. Right? And if we ask the question, so let's put these numbers in first. And if we say that there is a geometrical interpretation, so from geometry, we're going to say that the absolute value of some number x is the distance between 0 and x on the number line. Oops. All right. So let's now put in some of these that we had. When we looked at the point 2, I'm asking how far is it from 0? And this is showing us that we have a distance of 2 units, which is what we got in that first case. Let's look at well, if I ask what is the absolute value of 0, what is its distance between 0 and 0, then the answer makes sense. There is you didn't move, so your distance is 0 units. On the other hand, if I come over here and I look at -3, I'm asking what is the distance between 0 and -3. This distance would be 3 units. Right? So the negative is just telling me, in the case of this number line, that I was moving to the left of 0, but my distance is 3 units. All right, let's do a few more simple examples and then move on. So the key thing to keep in mind is this definition of the absolute value. Whatever the expression is between those two parallel lines, it remains the same if we've gotten something positive or non-negative. Aha. All right. So if the number is non-negative, then we will just take that number itself. If the number happens to be negative, then I take the opposite, the negative of that number. All right, so continuing, let's do some more exercises. So we were at part 3, let's look at part 4. Now notice for the next one here, you have the absolute value, but there is a negative sign on the outside. Right? It's on the outside of the absolute value. All right. So it's almost like a grouping symbol. So here, this is essentially the absolute value is our grouping symbol. We're going to work on the inside first, just like you had followed your order of operation. And in doing this, when I evaluate, I'm going to bring back the outside minus sign. That's a little bit long there. And what do I end up with? The absolute value of -5 is positive 5. Right, so I'm just changing this to a regular bracket now. And my final answer is -5. Right? So notice that when we said above that whatever the input is, the output is always positive. In purple here, the output of the absolute value of -5 is positive, but there's something else acting on it. So be careful. Do not just jump to conclusion and say that my answer is always ends up being positive without paying attention to what is going on in front of or with that expression. Okay, part 5. It's fine. We can sometimes have, let's look at the next question. Sometimes we can have a whole arithmetic expression that we have to evaluate. This is like working again inside a bracket, so we'll need to work inside here first. And in doing that, we end up with 3 minus 4. 3 minus 4 is -1. All right, looking at the absolute value of -1, it is 1. By the way, as I said before, we sometimes call another name for the absolute value is modulus. You'll hear about modulus much later when we are talking about complex numbers, but typically when dealing with real numbers, it's usually preferred that we talk about the absolute value. All right. Now, all of these questions were nice so far. You were just evaluating and we could end up with a nice answer. You have done or worked with problems where you might have irrational numbers. Right? So we have done our surds or radicals, And we have seen some irrational numbers like root 2, root 3, pi. Just to give you an idea, root 2 is about 1.4, root 3 is roughly 1.7, and so on. Pi, as you know, as a decimal, it's roughly 3.14, etc. Now, oftentimes when we are working, we want to leave our answers as exact as possible. That is, we want to leave these square roots or pi in our answers. So we could be given something like this, which says, let's do 2 minus pi. And I asked to rewrite or simplify this. Now I want to write this without changing it to a decimal, right? So I want you to simplify by removing the absolute value symbol, all right? And do not estimate, or do not leave your answer as a decimal. We want an exact answer, right? So exact answer only. Okay, so these are my instructions. All right, now although I don't want to leave my answer as a decimal, I'm going to look at what's on the inside here, because I have to decide, is this positive or negative? All right, so let's show our thinking here. And if we look at 2 minus pi as an approximation, it's 2 minus 3.14. So I would end up with something negative 1.14. You didn't have to evaluate that. All I'm interested in is whether this is positive or negative. So since I know by estimation that the way it is written is negative, I can now go back to my problem and say, okay, 2 minus pi, this is a negative number. I will use the lower part of my definition, which would be take the negative of whatever the expression is that I have. It's up to you now. We typically would probably want to rewrite this, and we can rewrite it as pi minus 2. That is, just expand, and I like to leave my answer with a positive, if I can, start my answer with a positive term rather than a negative term. Let's try that again with a different irrational number. Okay. So if we look at, say, number 7, if I had 1 minus the square root of 2. Okay. Now again, I can think about what's inside here. This would be 1 minus 1.4. So the result is a negative. That's for the interior. So it's negative 0.4. But the output coming from the absolute value must be positive. Hence, I will want to write this as negative of whatever is on the inside. Expand, that is, do my distributive property. I have negative 1 plus root 2. As I said, sometimes we might turn this around and write it as root 2 minus 1, because whenever we're given the opportunity, we might not want to start with a negative number. But either result would be fine. Okay, so continuing. Oops. If we looked at, say, using this idea, square root of 2 is approximately 1.4, square root of 3, 1.7, and we could say I want negative of the absolute value of 3 minus 2 root 2. Okay, so how will I write my final result? And I want the exact answer. So no rounding off. The decimals there were given you, or the approximation there were just to give you an idea of what would I end up with in here. So I would have 1.7 and 2 times 1.4, 1.7 minus 2.8. This result will be negative. So I would first, so writing back my minus sign, if I work on this part, the absolute value part first, it would be negative of whatever is inside, root 3 minus 2 root 2. Okay, let's evaluate what is inside, or it's up to you. You know enough math at this stage that you should be able to eventually write my final answer as this, right? So whether you went through the steps, individual steps, but your final answer will be root 3 minus 2 root 2. It's overall negative, oops, because we have a negative sign on the outside. Right. All right. Okay, I think we have a good handle on that now. So what is the point or the purpose of this absolute value? Let's look at one of the things that we can do with it. So the first thing that we can do is we can find the distance between 2 points, say on a number line. If we have any number line, if we have a number line, and this is A and this is B, and we want to find the distance between them, we say that distance is equal to the absolute value of the difference. So we can write A minus B, absolute value of that, or B minus A. Let's look at it for 2 examples. All right. So let's start out simple. I'm going to do one example here and one over there. So if this is 0, if I chose 0.1 and 0.4, then from the diagram here, I can see that my distance is 3 units. I could literally count the steps. Let's see what we get. If I'm looking at it, I could do 1 minus 4, which would be the absolute value of negative 3, but the absolute value of negative 3 is 3. Or, as you saw, it didn't matter the order that I put them in, as long as I subtracted the one endpoint from the next. So here we have, sorry about that. Here we have 4 minus 1, and that is equal to the absolute value of 3, but the absolute value of 3 is 3. So again, it doesn't matter the order that I put them in, I will end up with the same result. Does it still work if I have a negative and a positive? So let's look at this. 1. All right. Suppose we took -2 and 3. If I'm on the number line, I can count 1 step, 2, 3, 4, 5. So my distance is 5 units. Let's look at it from the algebra point of view, pretending that I couldn't see the number line. And it's just a difference between the endpoints. Endpoints are -2 and 3. If I put them in one order, I get the absolute value of -5, which is 5. Or if I put them with 3, the final endpoint minus the initial or lower endpoint, I would have 3 minus -2. Watching my signs, 3 plus 2, we end up absolute value of 5, but this is 5, right? So as I said, finding this distance is not a problem, particularly on the number, well, when we're doing the number line or using two numbers on a number line, we just take the difference between the endpoints and their absolute value, since distance is always a positive quantity. What makes it useful is if I were doing something, say, here's an application. If we were talking about, we have, this is my thermometer, and we could say that we have, or the coldest temperature that we had in a particular day was, say, let's say -10 degrees Fahrenheit. And then the highest temperature for that day was, say, 37 degrees Fahrenheit. I could ask, what was the temperature change for the day? And that would just be equal to my difference in temperature. If this was a final temperature for the day, this is the initial temperature or your morning temperature, then I could do T final minus T initial. We ended with absolute value of 37 minus -10. So we got 47 degrees, absolute value of 47, or simply a change of 47 degrees in Fahrenheit for our change in temperature for that day. Okay. Another application, or rather aside from distances that we were looking at, and these distances, yes, we'll do a lot in math, but as we saw here, applications, how much did the temperature gauge move in a particular day when we've recorded the high and low temperatures. We could also use this absolute value, or we actually use this absolute value when finding the square roots of certain numbers. In fact, the definition, if I take the square root of a number that's squared, it actually is equal to the absolute value of x. Oftentimes when I find, say, the square root of 25, you didn't write the answer was -5. You just clearly wrote square root of 25 is 5. This is sometimes called the principal square root. So the principal square root is an absolute value and is always positive, right? When you were, if you have an equation, so let's look, if you were solving an equation, solving x squared equal to 4, yes, it's true that I say x is plus or minus square root of 4, but when evaluating this part, square root of 4, I will use that principal root, which is, it is just 2, so it's plus or minus 2. There are two results for taking the square root. But we don't say, right? So we don't do square root of 4 is not equal to negative 2, despite the fact, although 2 square is 4, whoops, 2 squared is 4, and negative 2 all squared is also 4. So just make a note of that. We will be using, when we're dealing with square roots, we'll always be dealing with that principal square root, which is that absolute value and hence always positive. All right, let's get back to a little bit more abstraction. We've been dealing purely with numbers here. So let's go back to the idea of your absolute value. So just to recap, whenever we have the absolute value, it is itself if x is greater than or equal to 0 or non-negative. It's negative x if x is negative. So if we are given now some expressions, all right? So if you're given these, say, expressions, let's see what they mean. Absolute value of x minus 5. There would be two meanings to that. It would be itself, x minus 5, if that thing, I guess I don't need a bracket, if x minus 5 is greater than or equal to 0, or negative of itself, if this is less than 0. Let's just look at this a bit. Notice both of them, they're the same expression before the inequality. If I solved for it, you will get that x is either greater than or equal to 5 or x is less than 5. But we'll worry about the usage of what's going on. Why are we switching from 0? And now we are switching to some other place when we solve for x. All right, but we will get to that probably in our next lecture. Today's lecture should be, or our next topic actually. So let's see what we would get if I write another expression. So this time 2x, say plus 3. There must be two parts to it. Either itself, if we had that expression, 2x plus 3 is non-negative, or the negative of the expression, if 2x plus 3 is less than 0. Again, I'm just checking how well you remember how to solve these for x. And if I do, let's see what we would get. So I'll give you a minute to work out, make x the subject of the inequality, and then you compare with what I am going to write down. Okay. All right, so you can compare with what you have with what I have. You should have that the key point, instead of moving from 0, you now have x is greater than or equal to negative 3 over 2, or the other part of the half line, x is less than negative 3 over 2. Right? But the key points were these parts, which is once I have the absolute value, there are 2 parts to it. Okay. So let's look at solving some equations now. So we're progressing. We've gone through just regular numbers. We are now going to move from the expression and looking at what I claimed our topic was today, which is the equation, solving absolute value equations. Okay. All right, so let's start out with the most simple example that we can have. The absolute value of x equal to 3. Find x. All right. All right, so in solving this, recall that we have 2 possibilities. We have when or if x is greater than or equal to 0, then we would have just plain old x. Or the second case, when or if x is negative, right, then we would have, if I look at the absolute value, I would change it to negative of whatever is there is equal to 3. Solving for x, I end up x equal to negative 3. So this is giving me a proposed solution, or 2 proposed solutions. My solutions are x is equal to 3 or negative 3. Let's check, is this true? So as we go through, let's check. When we're checking, we go back to the original equation. So I'm going to substitute. Is the right hand side equal to the left hand? So yes, when I remove the absolute value, this is true. Hence, I'm absolutely sure, no pun intended, that the result x equal to 3 is true. Let's check the other side. If I take the absolute value of negative 3, is this equal to 3? And we end up 3 is equal to 3. So again, the second solution is true. Hence, I can be assured that my answer is really x equal to 3 or x equal to negative 3. All right, let's get a bit more complicated and see what's going on. We'll look at the meaning behind this in a little later. All right, so again, we want to solve the equation absolute value of x minus 2 is equal to 4. I want to solve that for x. All right, so again, there are 2 possibilities. We can say when the expression is non-negative, we'll have one thing, right? So I'll work underneath, or I will have when x minus 2 is negative. All right, what do I have? In the first case, I would just have the positive, just that expression alone is equal to 4, or I have, just writing this, and then we'll look at them and solve individual equations. All right, removing the brackets, x minus 2 equals 4. So x equal to 4 plus 2, x equals 6. It's up to you how you want to solve this. We could first divide both sides by -1, but I see that the majority of you are probably going to just expand, and that's all right. So negative x is equal to 4 minus 2. Negative x is 2, hence x is -2. Right? So these are our proposed solutions. We don't know if they're correct yet, not until we check. When you're doing this, when you're doing these problems, many times you can do a mental check, but since I'm showing what the technique is, I'll actually be physically writing them out. So I would go back and I'm checking, is 6 really a good solution? Is this true? 6 minus 2 is 4. Absolute value of 4 is 4, hence it's true. And so I am happy with that solution. Going on the other side, again, remember the substitution occurs in the original equation. And I have absolute value of -4 equal to, is this equal to 4? And yes, it is. Absolute value of -4 is 4. So both solutions are true. I write my final solution. So my solution is set of x's such that x is equal to -2 or 6, or just a plain comma. So two solutions are there, right? And both worked. Any questions? Okay. All right. Let's continue. Let's see if we get a good handle on this. All right. So question number 3. If we have absolute value of x minus 2 minus 6 equals 0, we want to find x. Okay, all right. We're going to change up a bit. After a while in doing this, you're going to get a bit lazy and you're going to say, boy, I don't really need these parts that I'm showing. Right, so this part about when x is such and such, I'm not going to bother to write it. But the understanding is that there are two sides or two parts to your absolute value. We'll come back and use these inequalities a little later. But for now, we're just going to be a bit lazy about it and drop them. So let me just take out all that writing there. Right. Okay, so as I go on, I'm just going to, and this will be probably more natural for you guys. So in doing the solution, I'm going to say there are two parts. Either it is itself, or it's a negative of the expression inside that absolute value. Notice I didn't change the signs inside the absolute value. It is exactly the same terms, and you are either keeping it with a positive sign or you're including that negative sign in front of the whole expression. All right, let's proceed to solve. Removing the brackets, I would have x minus 8 or x equal 8. So I'm done with this side. This is my proposed solution. Distributing like many of you like to do, I end up negative x minus 4 equals 0. Minus 4 equals x. So these are my two proposed solutions. I'm going to check. Again, when I'm checking, I'm going back into the original equation. All right, so when I substitute, I'm asking, is this equal to 0? Simplifying inside the bracket, inside the absolute value, I end up with the absolute value of 6. Absolute value of 6 is just 6. 6 minus 6 is 0. We end up 0 equals 0, so that's good. I know that the proposed solution, x equals 8, will work. Going to the next one, x minus 2 minus 6 equals 0. Substitute again for x. Do use your brackets when substituting. All right, absolute value of negative 6 is 6. 6 minus 6 is 0. 0 equals 0. So again, both solutions work. So I can come back and conclude that my solution is a set of x's such that x is equal to negative 4 or 8. Two possible solutions. All right, now that you have the hang of it, well, we're still going to do some more, but let's look. And so that was number 3. Let's look at number 4. Okay. All right. Someone is asking, what's the point of checking? You've done your work already. Don't worry, you'll see why. Let's look at the next problem here. So we want to find our x again. And as I said, we're going to go through the shorthand way. That is, we're just going to take whatever the expression is in the absolute value. We're going to take the positive, or we're going to take the negative of it. All right, now that I have these two equations, let's solve for x. Removing the brackets, I have x plus 8. So x equals negative 8. Going over here, removing the bracket, negative x minus 3 plus 5 equals 0. Negative x plus 2. And so 2 equals x. So these are my proposed solutions. So let's check. All right. So let me write my equation again. Original equation. Do not use the, whenever we're checking, we don't use, or we try not to use the derived equation, the equation that we wrote. Right? If we can always start from the very first thing that was given, that's what we will do. All right, if I put in negative 8 here, negative 8 plus 3, we end up with the absolute value of negative 5, and asking, is this sum here equal to 0? What do I get? Anybody sees it? So I have 5 plus 5. Is this equal to 0? 10. Is this equal to 0? It is not equal to 0. So it turns out that x equals negative 8 is not a solution. This is something that we call an extraneous solution. Right? It's a solution that came about because of, it's a solution that came about because of probably the method that we're using or so. All right, let's look at the next one. Let's see if it works. And we would have 2 plus 3 plus 5 equals 0. Absolute value of 5 plus 5. Is this equal to 0? We end up with 5 plus 5. Is this equal to 0? Oops, messed up here. 5 plus 5. So 10, is this equal to 0? And it's not. So again, we have another extraneous solution. So it turns out here that when I write my final solution, my solution is actually the empty set. It has there are no values of x which can make this equation true. All right. Before I move along, let me just look at this equation again. So we have we have, let me just write it here, x plus 3 absolute value plus 5 equals 0. All right. So let's look at this equation. If I make x plus the absolute value of x plus 3 the subject of the equation, well, we would have the absolute value of x plus 3 is equal to negative 5. Now, one of the things that we know is that the output from an absolute value is always non-negative. That is, it can be 0 or a positive number. On the right-hand side of this equation, I have an actual negative number. Right? There is no number, there is no real number that can satisfy this, right? So there is no real number that is both negative and non-negative. And hence, based on that argument, then we can conclude that the solution is the empty set. So we're seeing that if we can argue this and give reasons, just like I've shown here, the output is non-negative whenever I have an absolute value, yet it is showing a negative number. This is equivalent to me writing all of the parts that we did in question 4, or the early part of question 4 with all those lines, which showed exactly how we reached the two solutions, and then we checked them and so on, and ended up eliminating both as possible answers. So yes, this is one of the reasons why I kept saying we have to check. Ideally, you're supposed to check every equation as you solve them. All right, same thing. Let's look at another. And here we go. X minus 2 absolute value plus 10 is equal to 2x. A little bit different. We don't know. We can't, even if I did this, even if I should write the absolute value of x minus 2 is 2x minus 10. And let's say this is 0 or positive, so it's non-negative. I don't know the value of x. I can't tell, is this positive or negative, and how much larger is it than 10, so that is the overall result positive or negative. So we actually have to go through and use our algebra to work out each of these, or to work out and look at the possible solutions. All right, so let's go through. Oops. So our solution. Again, I'm not going to bother writing x minus 2 is greater than or equal to 0. I'm just going to go into it. So we have the first part here, which is, let's take x minus 2, the positive part. The other part didn't have anything about with an absolute value, so I don't really care what's going on that side. The sign, the symbol or sign is just the same as you had before, as you have present. X minus 2, negative of this, plus 10 is equal to 2x. All right, let's work out removing all the brackets. We end up x plus 8 equal to 2x. I'm going to get all my x's on one side, so I subtract x on the right side. X equal to 8. Let's expand here, negative x plus 2 plus 10 equal to 2x, group-like terms. I'm going to move my x's to the right-hand side. I end up with 3x equal to 12, dividing by 3, x equal 4. So I have two possible solutions. I must check them. Right? All right, so if I did the first one, 8 minus 2 plus 10, is this equal to 2 times 8? 6 plus 10. I end up with 16 equals 16, so I'm happy with that first solution. Okay. All right, let's check the next one. And if we do, we have 4, sorry. Right, we end up with 4 minus 2 plus 10. Is this equal to 2 times 4? And that's 8. Absolute value of 2 plus 10. 2 plus 10 is 12. And 8 on the other side is, so clearly this is incorrect. So this is not a solution. Right? So the only solution, so in writing my solution set, my solution is the set of x's such that x is equal to 8. So here we have a case where we only ended up with one solution. So it's important that as you go through the algebra, you do check, you go through the process, you found your answers, answers. Normally there are 2 coming out, and once you've done that, then you check and see if it really is a solution, and then write your final solution clearly. Make sure you show it in a clear fashion. We're not going to search your page to find out what your answer is, or if you're including it or not. So it must be absolutely clear what you have, what your results are.